Good day everybody, we've been given this question. We are expected to integrate integral root of x positive root of x squared positive 3 times dx. Now it is imperative to understand integration of this nature are always asked for high level entrance exams and scholarships exams. So it is imperative that you learn how to handle such questions. So having given you this question, let me just get it started. So foremost, what I wish to do is I would like to make the following substitution. Let x positive square root of x squared positive 3 be equal to some u. So I'm going to rewrite this as root of x squared positive 3 is equal to u negative x. Then I will be squaring both sides. So when you square both sides, you get root of x squared positive 3 raised to the power of 2 is equal to u negative x raised to the power of 2. You expand this, you get u squared negative 2 times u times x positive x squared. You expand, you square this, the square root and the square gets neutralized, giving you x squared positive 3. X squared gets cancelled. Now what I wish to do is I would like to move this u squared to this end and I get a quantity like this. Then I wish to bring in negative 2 times u down, and then I would like to take a negative sign out and then rewrite x. Negative will become positive, so therefore x is equal to u squared negative 3 divided by 2 times u. This is what we have got. Now I'm going to get dx, so differentiating both sides we get. Now for this I will be employing u over v form. So differential of x is going to be dx. This is going to be 2 times v times differentiation of u squared negative 3, that's going to be 2 times u times du, followed by negative u squared negative 3, differentiation of 2 times u is going to be 2 times du divided by 2 times u raised to the power of 2. Now du is common, so you can take it out. Now this is going to be 2 squared u v negative of 2 times u squared negative 3 times du divided by 2 squared and u squared. Now this can be further rewritten as 2 times u squared u into, now this is actually u, right, because 2 times u, I have just taken it as v, it's u. So this is going to be 2 squared times u into u is u squared negative 2 times, so if I have a positive b divided by c, I'm going to write it as a over c positive b over c. So this is going to be 2 times u squared divided by 2 squared u squared negative 2 times of u squared negative 3 divided by 2 squared u squared times du. Now this is equal to, right, so now clearly you can see that the 2 squared and the u squared they can get cancelled, so giving you 1 negative. Over here a 2 and a 2 gets cancelled, so it's going to be 1 negative u squared negative 3 divided by 2 times u squared times du. Now this is going to be my dx, so this is what I've got. So therefore integral root of x positive root of x squared positive 3 times dx is equal to integral, in place of x positive root of x squared positive 3 you can substitute u, right, u is substituted, and in place of dx I can substitute 1 negative of u squared negative 3 divided by 2 times u squared times du. So this is going to be u raised to the power of 1 over 2 I'm just distributing the value, times u raised to the power of 1 over 2 times u squared negative 3 divided by 2 times u squared times du. So this is what you've got. Now this can be further rewritten as integral u raised to the power of 1 over 2 times du negative. Now 1 over 2 can be taken out. Now push this 2 to the numerator, so it's going to be 1 over 2 negative 2 times u squared negative 3 times du. So this is going to be integral u raised to the power of 1 over 2 du negative 1 over 2. Now distribute u raised to the power of 1 over 2 negative 2 times u squared. So that's going to be u raised to the power of 1 over 2 negative 2 positive 2. Distribute this is going to be 3 times u raised to the power of 1 over 2 negative 2 times du. Now this can be further rewritten as u raised to the power of 1 over 2 times du negative 1 over 2. Now negative 2 positive 2 goes off, giving you u raised to the power of 1 over 2. Of course du is there, so you can substitute du there, or I should say place du there. So now if I were to bring this negative inside, it will become positive. So it's going to be positive 3 over 2 times integral. Now if you were to simplify this, that's going to be 1 negative 4 divided by 2. That's going to be u raised to the power of negative 3 divided by 2 times du. So this is what you've got. Now what you can do is you can directly integrate this. Now what I want to do is I actually want to take u raised to the power of 1 over 2 and then simplify it, but it's okay, you can just directly integrate this. So this is going to be u raised to the power of 1 over 2 positive 1 divided by 1 over 2 positive 1 negative 1 over 2 u raised to the power of 1 over 2 positive 1 divided by 1 over 2 positive 1 plus 3 over 2 u raised to the power of negative 3 over 2 positive 1 divided by negative 3 over 2 positive 1. Now let me go to this side of the page. Okay, so I can rewrite this as u raised to the power of 3 over 2 divided by 3 over 2 negative 1 over 2 u raised to the power of 3 over 2 divided by 3 over 2 positive 3 over 2 u raised to the power of, this is going to be negative 1 over 2 divided by negative 1 over 2. Now I'm going to take u raised to the power of 3 over 2 out, so it's going to be 1 over 3 over 2 negative 1 over 2 times 1 over 3 over 2 followed by 3 over 2. You flip this, you get negative 2 over 1, and this is going to be u raised to the power of negative 1 over 2. So this is equal to u raised to the power of 3 over 2. You flip this, you get 2 over 3. In fact 2 can be cancelled, giving you 1 over 3, and over here 2 can be cancelled, giving you negative 3 u raised to the power of negative 1 over 2. So this is equal to u raised to the power of 3 over 2. 3 is the LCM. 2 negative 1, that's going to be 1 over 3 negative 3 u raised to the power of negative 1 over 2. So if you have to rewrite this, this is u raised to the power of 3 over 2 divided by 3 negative 3 times u raised to the power of negative 1 over 2. Now but my u is x positive root of x squared positive 3, right? So if you had to substitute that, this is going to be, in place of u, you substitute x positive root of x squared positive 3. This is raised to the power of 3 over 2. You got a 1 over 3 there, negative 3 times. Now you can push this u down, so it's going to be root of, now let me just take it like this, x positive root of x squared positive 3 raised to the power of 1 over 2. This is what I've got. Now what you can do is you can take the LCM. If you were to take the LCM, this is going to be x positive root of x squared positive 3 raised to the power of 1 over 2. So you multiply this, you get x positive root of x squared positive 3. Of course there is a 3 there, so probably you can place a 3 there. So this and this, they get product multiplied, and when you multiply that, you get 3 over 2 plus 1 over 2. That's going to be a square there, right? Negative, and that's going to be 9 there. So this can be further rewritten as x positive root of x squared positive 3 raised to the power of 2 negative 9 divided by 3 times root of x positive root of x squared positive 3 positive arbitrary constancy. Now this is the end of the solution. You can go through the solution and give your comments, like the video and subscribe. Thank you everybody.